Hey guys, so I'm here at Matt's workshop right now. And he's gonna explain to us a little bit of how switches work. Right, Matt?
Right, Dominique.
Awesome.
So a switch is really just a way of making electricity flow. Normally, the electricity is trying to get from one point to another point, say along a wire, and if you just had a wire, the electricity would flow.
Obviously,
but if you break the wire, then the electricity can't flow.
Yeah.
And a switch is something where you can join together the wire.
Yeah.
Usually, momentarily, but not always. For example, this one.
What is that?
This is a different type of switch. I just brought it to show you something else. So one is either on or off. So it might be like the switch you'd have on a fan that you want to stay on. Whereas
that's like an old school kind of switch, though.
Yeah.
This is like your time.
That's my kind of time.
This is like when you were maybe a teenager.
Yeah, that's how we used to have keyboards like that.
Seriously?
Well, they did used to program computers with switches like this.
Like this?
Mm-hmm. And then this is a type of switch that would get soldered onto a circuit board. That's maybe more like an old mobile phone switch, the kind of tactile. When you dial the number on an old mobile phone, felt a bit like that.
Cool.
And then this is an arcade switch. So this is just the same kind of thing in the bottom, but then it's protected by this big plastic shell. When you're in the heat of the moment on an arcade game, you won't break the switch.
Why do you have this?
Just because I like to have a lot of switches around.
Awesome. So you're the best person to ask about switches?
Absolutely.
Oh, I love it. Now here we have these mechanical switches. What are these two pins?
When we spoke at the beginning about a way to understand a switch is to take a wire, cut it, and then when you join the wire back together.
Yeah.
So if you take those two ends of the wire, you have two terminals. So that's what the two metal parts are.
Ah, these are the two ends of the
Those are the two ends of the broken wire, and when you press the button on the top, it joins those two pieces of wire together. Yeah.
Okay.
And it does that in quite a special way, using the microswitch method, which was a big deal when it was invented, because it was a very reliable way of making a positive action switch on and off. And these are even more advanced because these are made for mass production. So when you see these switches being made, the metal parts are folded up out of these thin strips of metal, and they're all designed to then go into a machine that assembles the switches automatically. Wow. So a lot of effort's been put into not only making these incredibly reliable, like millions of times of switches before they break, but also that they're easy to assemble in a factory. Completely automated.
And I always wondered the difference between the white bottom and then the black bottom here.
If they're fully transparent, it's to allow the light to come out, but people do that in different ways. For example, this one's got a cut in the side of the shell, so that you can put an LED there and it will shine up through the top. And if it's got a solid black base, then you would have to put the LED in the top. You see that little round hole there?
Yeah.
And the little holes on the bottom. That's for pushing an LED in from the top.
Wow.
So that's how you can also illuminate a key. So the advantage of that is you've got the LED closer to the key, so you get more light out. But one of the disadvantages, and the reason we can't use it on the Raise, is that you have to solder the LED in, and then you can't take the key out.
And that's why we have reverse.
Well, we make sure that the top surface of the PCB is totally flat. Because if there was an LED on the front, then maybe it wouldn't fit through this hole, or it would do, but then it wouldn't fit through that hole, because there's quite a few different manufacturers of switches, and we want to try and maintain some compatibility.
Awesome. So I guess the safest bet would just have reverse mounted LEDs.
Yeah.
Or can this switch be mounted on the Raise?
Yeah, you could, but you'll block all the light with that one.
Yeah.
So if you're not interested in light, but you really love a specific switch, then you could use a switch and just turn off the lights.
And I see that there's so many different types of switches, right? I mean, different types of mechanical switches.
All the ones we're looking at here are pretty much all the ones that would fit into the Raise. So they have like this centre pin, and then they have the two pins here offset. It's called the Cherry Standard, because Cherry is the German company that first made that switch. But you have many other people who also make switches. So just like with a mechanical key switch, you get somewhere the two holes for the terminals for the broken piece of wire essentially are symmetrical. So that wouldn't fit in this, and that switch wouldn't fit in our hole.
No.
But these are probably the most popular, and you have the most choice here.
So there are three types of switches as well, right? The clicky, the tactile, and the linear.
Yeah, all of those things basically come down to the feel of the switch. So there's what the switch does, which is just connecting or disconnecting wires. But then there's the look and the feel of the switch.
Yeah.
So this one is extremely positive, and you couldn't knock this one on or off by mistake. So this would be like good for a safety switch. but you wouldn't want to play a game with it because it would take a lot of effort. Whereas this one is made for a very rapid fire, big button, so you can hit it easily with any part of your hand. And with a keyboard that is originally designed for typing, you've got a different set of specifications. Different people like different types of switches, and it's a very personal choice. But for example, a linear switch is just where the feeling as you depress the switch is the same, it stays the same. You also get different springiness, so the amount of force you need to put on to make the switch press. You could have a very light touch or a heavier touch. So this would be an example of a very heavy switch, and this would be a lighter switch. And then these ones, you can go on the website and look at the data sheets, and you see all these curves for how much force it takes to actuate the switch and then to deactuate it as well. And a linear is meant to be like as you push it, it takes a linear amount of force.
It's like just a smooth press.
A smooth press all the way down. And then, here's a tactile. If you press it fast, you don't notice the difference, but if you press it slowly, you feel like there's a bump in the middle.
And what causes that bump?
There's a kind of cam shape on the side of the switch.
Yeah.
There's the springy part is the metal on the one side, and it wants to make contact with this part of the metal here.
Yeah.
Okay, so when the switch is up, that little wing on the side, on the left side, the brown bit, is pushing it away. And as you push it down, it moves out of the way and the thing can come into contact, so that's what's drawn to wire. But if you look at the shape of the brown thing, it's not just a straight line, it has a little wiggle in it. And that wiggle interacts with the springiness and the shape of that piece of metal to give that little feeling in the middle. So you get like a positive action that it is in that position. I prefer that. I don't like the linears without any feeling. I don't want to press the key all the way to the bottom. I want to know when it's fired enough and then move on. And
I guess it's slightly similar to the clicky, because with the clicky you can also feel that feedback.
Yeah.
But it just has.
And it makes a sound as well.
But what causes that?
You see, there's actually two pieces there. The white plastic bit gets to a certain point and then it pops out of the way. As that white bit hits the bottom, that's what makes the sound. And I think people like that because the original keyboards that came with the original kind of mainframe computers with these incredibly noisy, clicky keyboards.
Awesome, Matt. Well, thanks for explaining to us the different kinds of switches and taking us back in time with your ancient switch technology. Exactly. Guys, if you want to learn more about switches or anything about technology, make sure you get to subscribe our video. And thanks again, Matt.
You're welcome.
Bye, guys.
Guys, we need to work. No, we have to play pinball. It's important. Let me just get the Daleks up.
If you're interested to learn more about the Raise keyboard, you can click the subscribe button. Or if you're interested to purchase one of these beauties, you can head over to our website at dygma.com.